Oke, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, guys. How are you?
Good afternoon, sir.
Good afternoon, sir.
Good. How about you?
Fine, thank you. Okay, let's wait for the others. Okay. Okay, so before we start our lesson, let's pray. Pray begin. Amen. Okay, as usual, before we start, let's fill in the attendance. Please go to your groups and fill the attendance, please. Anybody absent today? No? Everybody's in the classroom?
Yes, sir.
Okay. Okay. I'm sending also the link to the chat room. So you can also go to the link from the chat room. All right. Okay, let's start our lesson today. Okay, as usual, I'm sorry, I'm going to turn off my camera because it's difficult to write if my camera is on. So please don't mind about this. Okay. So this is lesson number 18. Video conference lesson number 18. August 27th, 2020. So in this lesson, we are still talking about modern atomic theories, yeah, or modern atomic models. Last lesson, we discussed a little bit about modern atomic theories. Let's review what we did lastly. Okay. Let's one of the student, let me see from the list. Okay, Arsha Gipari.
Yes, sir.
What we learned last lesson?
About Bohr theory and modern atomic model theory.
Okay, modern atomic model. What you learn about modern atomic models?
The apa? Can I use bahasa, sir?
Yes.
Jadi kemarin itu mempelajari tentang siapa penemunya, kemudian tentang dualisme atau apa getaran sama partikel, yaitu
Getaran. Jadi gelombang.
oh ya gelombang maksud saya.
Yes.
sama partikel.
Duality, isn't it?
Yes.
It is about particle and what is the second one in English? Particle and
Wave.
wave. Yeah, thank you. Okay. Damar, who say about this? Particle and waves. Damar, which scientist told about the duality of the object?
I forget, sir.
Okay, anyone remember?
Louis de Broglie.
Louis de Broglie.
Yes, it is Louis de Broglie, isn't it? Louis de Broglie is the one who talk about the duality, of a small object, which we call as an atoms. It's like a particle and like a waves. So this is become the what we can say the what basic of the quantum, isn't it? It is the basic of quantum theory. Okay, good. What else? What else we learn?
Uncertainty.
Uncertainty. You mean uncertainty principle, isn't it?
Yes.
Okay, who can say about this one, uncertainty principle?
Heisenberg.
Okay, it is said by Heisenberg. The name of the scientist who proposed this is Heisenberg. So that's why the name of the principle is Heisenberg uncertainty principle. But who can tell me what the principle said? What's the insight of the principle? Naufal Rizky Sufyan, what do you think? You can use Bahasa if you have difficulty in English.
Yes, sir.
What is uncertainty principle?
Ilmu yang tidak pasti.
Yeah, can you open a little bit? Can you explain a little bit what does it mean?
Jadi kayak misalnya kayak kemarin itu yang kucing ditaruh di box, itu kan kita tidak bisa melihat kucingnya. Jadi tidak pasti antara kucing itu masih hidup atau sudah mati. Jadi 50-50.
50, okay. Okay, let's go back. Zayan?
Yes, sir.
What else do you understand about uncertainty principle? Apalagi yang kamu paham tentang uncertainty principle? Okay. Look at again this. Okay. Okay. This picture are telling you about uncertainty principle. Do you remember this picture?
Yes, sir.
Okay. So it's talking about what? Yes. Yusuf Anwar Winahyudi. What do you think? What is uncertainty principle?
Yeah.
What is uncertain in the experiment? What is uncertain?
Oh.
Yes, okay. Satrio Anggara, what do you think? What is uncertain?
Tidak pasti.
I mean, what is uncertain is not the translation. I'm looking at the definition. What is uncertain in the experiment? Not the translation. Two things which is uncertain. Remember, this one is showing you what? And this one is showing you what?
Can I answer, sir?
Yes, of course.
There is about momentum and position.
Good. So it is uncertain, right? The position and the momentum or the movement. The momentum we can say also in daily life is a movement, because momentum in physics, this is mass time velocity, which is the movement regarding to the mass of the object. So at the same time, the position and the momentum cannot be certain, isn't it? So that's why it is called as uncertain, because the momentum and the position at the same time cannot be defined or cannot be found. It is uncertain. Okay, is it clear? Okay. Okay, that's as Heisenberg. And the last one, we were talking about the Schrodinger, isn't it? Schrodinger quantum mechanics. And there was video about this. Let me again play the video about the cat experiment. Okay, is okay, now it's opening. Can you see the YouTube now? What you see in your screen?
Black, sir.
Black screen.
Black screen.
Yes, it is black screen.
Okay.
I can.
Let me stop sharing and then share again. Let's. Okay. Now can you see?
I can see, sir. I can see, sir. I can see, sir.
You can see.
Yes, sir.
Good. Okay. Again, we are going to watch the video about the Schrodinger cat experiment. Sorry about the confusion.
Austrian physicist Erwin Schrödinger is one of the founders of quantum mechanics, but he's most famous for something he never actually did, a thought experiment involving a cat. He imagined taking a cat.
It is very important, guys. It is say that it is a thought experiment. Thought experiment. Thoughts mean is it is pemikiran, ya. Jadi percobaan dengan pemikiran. Thought experiment. Actually, Schrodinger never did this experiment. He never used the cat, but just he thought about this. He thought about how about if I have a cat and I put it into the box, and then he made the theory according to the thoughts. Okay. He imagined
cat and placing it in a sealed box with a device that had a 50% chance of killing the cat in the next hour. At the end of that hour, he asked, "What is the state of the cat?" Common sense suggests that the cat is either alive or dead, but Schrödinger pointed out that according to quantum physics, at the instant before the box is opened, the cat is equal parts alive and dead at the same time.
So normally in our daily life, it is impossible to have the cat in both state, either alive or die at the same time. It's impossible, isn't it? But when we're talking about the quantum physics, quantum theory, then it is possible. Yeah. So because we cannot see the exact state of the cat, so we will think that the cat is in a state whether it is live or die. So it is like the picture you see here, the screen. The cat is between life and die. Yeah, it is at the same time.
It's only when the box is opened that we see a single definite state. Until then, the cat is a blur of probability.
So it is talking about probability. This is very important. This word is important. What does it mean in bahasa probability?
Kemungkinan.
Kemungkinan. Yes, good. So it is a kemungkinan. We are talking about the probability. We are not talking about the exact thing. Okay? So in quantum, we are going to talk about probability.
Half one thing and half the other. This seems absurd, which was Schrödinger's point. He found quantum physics so philosophically disturbing that he abandoned the theory he had helped make and turned to writing about biology. As absurd as it may seem, though, Schrödinger's cat is very real. In fact, it's essential. If it were
But either we are talking about the cat is live or die, but there is something real there. What is the real? The cat is real. Ya, walaupun kita tidak bisa memastikan probability apakah kucingnya itu mati atau hidup, tetapi yang pasti ada kucing di sana, isn't it? Although we cannot know the exact state of the cat, whether it's live or die, but what is fixed, what is exists, the cat is exists. So we cannot say that there is no cat there, but the cat we know that it exists, but we don't know the state of the cat, whether it's live or die.
weren't possible for quantum objects to be in two states at once, the computer you're using to watch this couldn't exist. The quantum phenomenon of superposition is a consequence of the dual particle and wave nature of everything.
So this is because what? We're talking about the probability. This is because of what? Actually, this is back to the Louis de Broglie theory that object, it can be like a particle and it can be like a wave. So that's why we couldn't know the exact position and exact momentum, like the Heisenberg say, right? So that's why we can only talking about the probability. So actually these three theory, these three guys are related to each other.
In order for an object to have a wavelength, it must extend over some region of space, which means it occupies many positions at the same time. The wavelength of an object limited to a small region of space can't be perfectly defined, though, so it exists in many different wavelengths at the same time. We don't see these wave properties for everyday objects because the wavelength decreases as the momentum increases.
So the wavelength or gelombang ya, panjang gelombang, the wavelength, because we are talking about the wave. If the wave have a wavelength, we cannot see the wavelength because it is about the wave. Because when the wavelength is increased, when the wavelength is decreased, the momentum is increased. When we have a bigger object like a cat here, cat is bigger object, so we can see the movement. We can see the momentum of the cat. If we can see the momentum, the wavelength cannot be seen. Yeah, so it is like that.
And a cat is relatively big and heavy. If we took a single atom and blew it up to the size of the solar system, the wavelength of a cat running from a physicist would be as small as an atom within that solar system. That's far too small to detect, so we'll never see wave behavior from a cat. A tiny particle like an
So because it is very small, the wave properties, ya, ciri gelombang dari sebuah benda, because it's very small, so we cannot see. Yeah, the atom is very, very small, so we cannot see the exact behavior of the atoms or the electron in the atom as a wave.
electron, though, can show dramatic evidence of its dual nature. If we shoot electrons, one at a time, at a set of two narrow slits cut in a barrier, each electron on the far side is detected at a single place at a specific instant, like a particle. But if you repeat this experiment many times, keeping track of all the individual detections, you'll see them trace out a pattern that's characteristic.
Okay, do you remember that experiment, double slit experiment? We're talking about this one last lesson, right? So it can be like like a particle that make only two accumulation, but at the same time also it will make wave-like properties that have interference like this that would make many accumulation. Yeah.
Of wave behavior, a set of stripes, regions with many electrons separated by regions where there are none at all. Block one of the slits and the stripes go away. This shows that the pattern is a result of each electron going through both slits at the same time. A single electron isn't choosing to go left or right, but left and right simultaneously. This superposition of states also leads to modern technology. An electron near the nucleus of an atom exists in a spread-out wave-like orbit. Bring two atoms close together, and the electrons don't need to choose just one atom, but are shared between them.
Later we are going to learn about this, how they will make a bond. This actually is about bond. But at this point, what we understood that here, we understood that the small object, has a duality characteristic. It is a particle and it is a wave. Yeah. And after that, because it is a small particle, we cannot understand or we cannot exactly know the position and the momentum at the same time. So because it's uncertainty. So what we can say is only the probability. Yeah. What we can say is only the probability. So this is what we're going to talking about today. Let's continue. Okay, just a review, but we spend many time for review, no problem. Okay, let's continue then now with the next thing. Can you see now the screen?
Yes, sir.
Okay.
Yes, sir.
So we finished about what Schrodinger. So we understood from Schrodinger that we are going to talk about the probability. Sorry, something not good with my presentation. Let me. Sorry. Okay, let me share again. Okay, let's continue then. Okay, after we knowing that things, we know about the duality principle, and then we know about uncertainty, we're talking about the probability. Now we are going to continue with the next thing. Now we can say about the modern atomic models. Okay, now we can say about the modern atomic model. Actually, modern atomic model, when you see this model, okay, let's take a look at the picture in the right side. Okay, this picture, it is look like which model? What do you think? It's resemble which model? It's look like which model? It is Dalton or it is Thomson or Rutherford or Bohrs? Which model which is look like this?
Bohr.
Bohr.
Yes, of course, it is Bohr's model, right? It's look like Bohr's model. There's a nucleus in the middle, and also there is an energy level, isn't it? So this model is very similar to Bohr's atomic models. Yeah, it is very similar to the Bohr's atomic model. That's why I told you at the beginning that actually modern atomic model or quantum atomic model is the revision of the Bohr's atomic models. Yeah, still we are talking about energy level, or what is the other name of this energy level? Do you remember?
Shell.
It's the shell. Yeah. So it can be n equal to 1, n equal to 2, n equal to 3, 4, and so on. Or sometimes we can use letters, right? N equal to 1, what letters it is?
K. K. K.
It is
K.
K, yes. K, L, M, N, and so on. So this is actually very, very similar to the Bohr's atomic model. What is the difference? What is different? The difference here now, we are talking about the probability. Now, look at this. We are talking about the probability. What is probability? Probable is kemungkinan. Probable regions, tempat yang memungkinkan, probable regions in which the electron might be found around the nucleus. Who can translate this one in bahasa? Probable region in which the electron might be found around the nucleus. Okay, what's to the place? Zain Al-Azhari. Can you translate it, please?
Oke. Kemungkinan wilayah di setiap which the electron
Might be,
ditemukan di sekitar nukleus. Mungkin ditemukan.
Yes. Might be found, mungkin ditemukan in around the nucleus.
Sekitar
Right?
nukleus. Yes.
Yeah. So that's region, what we call that region, we have a name for that regions. This region we call as the orbitals, guys. So don't be confused with orbit and orbital. They are different. Orbit and orbital. There are two things which are different. What is orbit? Anyone can say what is orbit? For example, our Earth is rotating in the orbit, isn't it? So orbit is a fate or way. Orbit jadi jalan ya, orbit. So for example, electron can rotate in an orbit, right? In a spatial fate or spatial way. That spatial way we call as an orbit. But orbital are different. Orbitals means the probable region in which the electron might be found around the nucleus. Kemungkinan kita mendapatkan wilayah, kemungkinan kita mendapatkan elektron atau kita menemukan elektron. That's an orbital. Yeah. So orbital and orbit are different. Now, the orbital is the place where we can or where we might. Is a place where we might or maybe is a place where we may or maybe find the electron. So this is may, probability, okay? Now the exact place of the electron can be known or not. Okay, can you answer my question? The exact place of the electron can be known or not?
Yes.
Apakah tempat pastinya elektron bisa diketahui atau tidak? The exact place of the electron can be known or not? Of course, yes or not?
I think no, sir.
I think no, sir.
Of course, no. Was we talking
Because
about Heisenberg uncertainty? We're talking about Heisenberg uncertainty, isn't it? And then we're talking about the cat, like the cat, right? Because we cannot see the electron, so we never know the exact place of the electron, but we can guess. Do you know guess? Menebak.
menduga.
Menduga. If you want to guess, then you have to know the probable region. Kalau kamu mau menduga, kamu harus tahu kemungkinannya, tempatnya di mana, isn't it? If you want to guess, you have to know the probable regions of the electron. And the probable region is orbital. Tempat yang kita duga ada elektron, itulah yang disebut dengan orbital.
Orbital.
Okay. Now, how to know the electron is in the orbital? Okay, ini baru dugaannya. How to guess the electron is in the orbital? Then we will use an address. Tahu address? What is address? Address? Apa? What is address?
Alamat.
Alamat, yes. If I know the address of the orbital, then I can probably find the electron, isn't it? Kalau saya mengetahui alamatnya orbital tersebut, kemungkinan saya tahu di mana elektron, isn't it? If I know the address of the orbital, probably I can find the place of the electron. But probably is important, yeah. Probable is important here. Probably we know the place of the electron. Okay. Now this address is called as quantum numbers. Okay, alamatnya, the address with 2D, right? It's written like this, or with 1D. I don't know, 1D or 2D. Okay, the address. The address in orbital is called as a quantum numbers. Okay, bilangan kuantum in bahasa. Bilangan kuantum itu adalah alamatnya. Quantum numbers is the address of the electron, or the address of the orbital that you will find the electron. You will probably find the electron. Clear? Okay, let's sum up what we see now. This thing is very important. One student, please. Okay, let me choose Muhammad Yusuf.
Yes, sir.
Can you sum up what we talk about in this slide? You can use bahasa if you have difficulty.
What, sir?
Can you summarize what we talk about this slide? Yang slide ini aja. You can use bahasa if you have difficulty.
Jelaskan model atomic model, habis itu orbitals.
Yes, what is orbital? Apa itu orbital?
Tempat kemungkinannya ada elektron.
Okay, good. And then? How can you find the orbital?
Nah, yes, how to can ya. Bagaimana habis itu quantum numbers, yes.
Quantum number is this as what? In daily life, what we call what? Quantum numbers.
Alamatnya, alamat orbitals.
Good. The quantum number is the address of the orbital where you can find the electron. Okay, is it clear now?
Yes, sir.
Okay, good. Now, so after we know this, okay, we have 4 minutes. Okay, let me give you this, the last slide. After we know this, modern atomic theory explain about the probability of finding electron around the nucleus by virtue of quantum numbers and orbitals. So by using the quantum numbers and orbital, we can find the probability of the place of the electron. This is actually the summarize of the this slide. Yeah. So two things is important: quantum number and orbital. Now we are going to see one by one. Now, quantum number specify the address of each electron in an atom. There are 4 types of quantum number. Ada 4 quantum numbers. Nah, seperti alamat, it look like what? Address. Address also we have different address, right? For example, if I'm asking you, where is your home? You will not say that only my home is in number 20. It is ridiculous. It is nonsense, right? How can I know number 20? There are so many number 20. You have to tell me in which street or in which complex or in which block, right? So it is impossible to find the address with only one information. For example, if you give me only the address with only block, it's important also impossible also to find the address. Or only street, it is impossible. So it must be the street, it must be the block, or it must be complex apa, which complex, or it must be which number. It must be knowing, isn't it? So it's the same like the electron. If you want to know the electron, rumahnya, the place of the electron, which is orbital, okay, then you have to give the address. And this address is called as quantum number. There are 4 types of quantum number. It look like a different address, right? It's like street, it's like a block, it's like a number. Okay, so for orbital also have different address. The first one we call principal quantum number. The second one we call secondary quantum number. The third one we call magnetic quantum number. And the 4th one we call spin quantum number. If you know these 4 address, then you can find the exact, not the exact, the probability of the place of the electron in the orbital. Jika kamu mengetahui 4 alamat ini yang dinotasikan dengan bilangan kuantum, kamu akan mengetahui kemungkinan letak elektron pada orbital. So, it's important to know this address. Now we are going to, after this, next week, we are going to see one by one. What does it mean, this address? Principal, secondary, magnetic, spin, it's show you what? We are going to see this one in the next lesson. For today, that's enough, I think. Okay, thank you for listening. Okay, don't forget at 3:30 we are going to have post test again. Thank you. See you next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir.
Thank you, sir.
Thank you, sir.